Good morning. My name is Won Yoon. I'm the Federal Program Manager. Also with us is Ben CPD, who is TPOC for the Advanced Reactor Safeguards. And Ben will join at the end of the presentation for during Q&A sessions. Okay. This is the new work scope added this year. This by ARS Advanced Reactor Safety Program, which is ARS. This ARS program is a part of a much bigger, which is Advanced Reactor Demonstration Program. And this is to address unique issues related to safeguards and security for the advanced nuclear reactor. Okay, next page. As an introduction to the ARS program, the goal of the ARS program is to address through R&D near-term challenges that advanced reactor vendor faces in meeting domestic material accountancy and physical protection requirement for advanced reactors. And the scope of this ARS program is for only domestic reactor only. So it deals with the NRC. And we have other DOE program under NNSA that deals with international safeguards mandated by IAEA. And the vision for this program is to reduce roadblocks in the deployment of new and advanced reactors by solving unique regulatory challenges and reducing safeguards and security costs and utilizing the latest technologies and approaches for the planned monitoring and protection of a nuclear reactor and nuclear reactor facility. I just want to emphasize that there's a scope in MPAC, which is Material Protection Accounting and Control Technology. MPAC is another NE program that deals with similar issues, but only related to the fuel cycle, which is during fuel cycle assembly for new or recycle of the fuel front end and back end. And this ARS program is for in the middle, which is a reactor and reactor operating issues for MCNA issue and physical protection. So next page, please. Okay, I'd like to introduce some of the objectives and priorities. This ARS program have two main areas, which is material accountancy and physical protections. And in terms of a material accountancy, the advanced reactors have quite unique challenges due to the exotic fuel types, mainly molten salt and pebble bed, which is different from traditional reactor with a discrete fuel assembly. So the material accountancy priorities, like is his bullet, regulatory issues and accountancy approaches and measurement technology for molten salt reactors, and accountancy accountancy approaches and monitoring technologies for pebble bed reactors, and also regulatory issues and measurement technologies for microreactors, and also regulatory issues use of HALEU, which is most of the advanced reactor will be using HALEUs. For the physical protection side, we like to, for advanced reactors are smaller in size, so the facility design and engineering security features, we need to mitigate measures with basically reduce human action or human presence at the site. So which is the first bullet. We need to reduce physical security operation cost. which is by drastic reduction on on-site responders. Also reduce physical security upfront cost and provide methods to advance of enhanced safety features and also consider unique sabotage targets. Next pages. Okay, this is just a copy from the Workscope and it's CT-4, Advanced and Small Modular Reactor, Material Accountancy and Physical Protection. It's a long title. And it's eligible for university, and the duration will be 2 years. And then award amount is up to 400,000. So rather than reading the entire scope, I basically cover the meat of the scope, and we are ready for Q&A for this ARS Workscope.
Okay, Juan, would you like me to unmute Ben?
Yes, please.
Okay, let me find him in the list here. Okay, Ben, can you hear us okay?
Yeah, I can hear you. Can you hear me?
Yes, yes, we can hear you just fine.
Okay.
If everybody who has questions would please type your question into the GoToWebinar question application. I'll be glad to read them for you. This is Julie Jacobson with the NEUP. Right now, we just have one question, and it says, is this work scope for computation or experiments or either?
It's
So this work scope would be for either. We're not, yeah, it's not for one or the other.
Okay. Oh, here come a few more questions. Will generic design basis threats be provided for, or could they be suggested for, a general assessment of the physical protections?
Yeah, that's a good question. I know sometimes one of the difficulties with universities on the physical protection side is not having access to, some of the sensitive information. That's certainly something that can be provided. So you might want to consider a good lab partner for that can help provide that guidance. But I know that's something that can be done in the past. There's different ways that you can look at more of a generic threat to try to stay out of the sensitive space.
Okay, next question. Does this work scope include development of small footprint neutron spectrometers that can actively or passively detect the emission of fast neutrons from radioactive materials as part of MCNA?
So the one thing I want to clarify here is that Juan had talked about is that we are focused on domestic regulatory requirements. So just keep in mind that if you're going to, for this particular area, if you're going to be proposing a project, we're interested in how how the vendors are going to meet NRC requirements for U.S. builds. So sometimes technologies may be a little bit more suited for the international safeguards area or for more of detection, remote detection, something like that. We're not as interested, we're not going to be interested in. We're specifically interested in materials accountancy needs that are going to be needed for various reporting requirements for NRC. So that being said, that particular technology, that could be something that might be needed for small reactors, for sealed cores. So that might be something that would be considered. But I do want to just kind of caution that the regulatory needs are not completely defined, and we do have some work in the larger program help define what those needs would be. So we're still trying to kind of understand a little bit more about what, what on that side would actually be needed in terms of measurement technologies.
Okay, next question. Will new reactor concept designs be supported?
No, I mean, new reactor designs would not be supported under this particular work scope. I can't speak to the other areas, but this is just focused on materials accountancy and physical protection for generic classes of reactors.
Can traditional LWR MCNA be used as a template for MCNA? Or so this would be, could you investigate this as part of the work scope?
So the traditional light water reactor MCNA, a lot of the basis for that centers around the fact that you have large discrete fuel assemblies, which are, frankly, difficult to steal. It's difficult to, take material out of there. And so the NRC requirements kind of take that into account. And the Part 50 and Part 52 licensing, in the Code of Federal Regulations has sort of a reduced MCNA set of requirements for those types of reactors. So when you talk about advanced reactors, if you're looking at something that's more of a traditional fuel assembly, and that could be a light water reactor type design, it could be even a sodium reactor type of design. When you have the discrete fuel assemblies, you're probably more likely to fall into that, existing MCNA approach. As you move towards more of the advanced or the more novel fuel types, like when you go towards the pebble beds or the liquid fueled reactors, increasingly different approaches are needed. And sometimes those approaches aren't necessarily spelled out that well in the regulations. But as you move more towards those novel fuel types, you're more likely to be in the Part 74 regulations, especially with the liquid fuel type of designs. So it really depends on the focus of, or what sort of general class of advanced reactor that you're interested in exploring.
Okay, could attractiveness assessments be included as part of the physical protection assessment?
So that could play a role. I think what I would maybe be a little bit more interested is not as much in attractiveness, because I think that's certainly something that's been done. I'm not sure that it's been done for all the different types of fuel and reactors, especially some of the new novel ones, but there has been, work on attractiveness in the past, both in the open side and on the, more on the sensitive side. But I think what we are interested in is kind of more along the lines of attractiveness along with sort of ease of access. So the physical protection requirements will probably take into account how difficult it is to access the material. So for example, if you have a sealed core versus, a sealed core that maybe just has a 20-year life or a 15-year design life, versus fuel assemblies or other types of fuel that has to be removed periodically, that could have an effect on both the MCNA requirements and the physical protection. So that sort of interface between and sort of taking into account the difficulty of access, I think, is something that we probably could use a little bit more help on.
Okay, I think this is our last question. If there was a company in industry and they were developing a pebble reactor and they also were looking at MCA regulations to design the reactor, they're just wondering, would an industry partnership be a factor in assessing potential proposals?
Juan, can you answer that?
Yeah. I think this is for university only. So they would be say, I would say no.
But they're saying a partnership with industry. Would that, you know, like when they're reviewed, would they get extra points? That's what it's asking, I believe. When the, like if they had a university submit the application and then they had a partner that's an industry partner who's looking at some of these same things.
Is
would
there any, I'm sorry I have to ask this question, but is there any reason that they can't do that? They can't partner with an industry as part of the this CINR area?
This is more like procurement issue. So I probably have to consult my
I see.
would,
What I see, Aaron Gravel has made a statement. It says partnerships are encouraged, but there are no additional bonus points for that in the review process.
Okay. Yeah, my
or they would not
familiarity.
get paid, right? Yeah.
Yeah, and my familiarity has been more with the lab partnerships. Certainly, we do encourage the partnerships just because it kind of helps to guide the work and make sure that we're not, especially if you can be partnering with somebody in the program, it helps to you know, kind of know where the gaps are and make sure that we're not reinventing the wheel. But in this case, because our ARS program is so tied to the vendors, yes, I'm glad that that's something that's encouraged, because if you're tied to industry, it kind of helps us to know that there's a specific need and a good application space for it. So you know, again, like it said, it's something that I think speaks to the fact that you that you're probably addressing a need, but you're not necessarily going to get bonus points for it.
Thanks, Aaron, for clarification.
Okay, next question. Is there a minimum of unaccounted for nuclear material established, since most methods are statistical?
Let's see, I'm not sure I'm quite understanding the question. So the
You mean like detection level?
Yeah, the requirements, those sort of details are listed in 10 CFR 74. And so it kind of depends a lot on the, you know, it's usually listed as like a percentage of the physical inventory. And so that can change quite a bit depending on the size of the reactor. So you know, a small modular reactor, you know, may still have a more significant amount of material, whereas a microreactor might be, will be quite a bit less. So that particular requirement, if that Part 74 is required for that type of a system, is going to change. So I think when you get into those sort of issues, I guess I highly encourage you to just make sure that you understand the regulatory space.
Okay. Are you looking at physical protection only from the viewpoint of diversion of material, or would you also consider a threat to the release of radioactive material?
Both. It's both diversion of material and theft of sabotage.
Yes.
You know, basically everything that NRC is interested in, and you know, in protecting the health of the public about.
Okay, let's wait about another minute. I don't see any more questions at the moment. Okay, here's another question. Would design modifications that result from an MCNA assessment, such as addition of accounting tanks, be captured by this activity?
Yeah, I mean, I think certainly anything that's you know, proposed as a design change, you know, particularly if you're looking at safeguards by design, security by design, those are all things that we would be interested in. It's really just a matter of if that's something that's applicable to the, you know, the particular reactor. So an accountancy tank may be more applicable to, might only be applicable to a molten salt reactor. I'm not sure that that's quite as useful for any of the other reactor design types out there. But we do highly encourage safeguards and security by design in this area.
Okay. Okay, let's see. Here's another one. Is there a safeguard by design document available for advanced reactors?
That's a good question. You know, there's been a lot of work on safeguards by design in the international community, and I know there are some documents on the IAEA side. That doesn't really help us quite as much here, just because of our domestic focus. That's something I would have to check on. I'm not aware of anything offhand that's kind of more like a guidelines, but I will say that that's, in a way, that's kind of one of our goals of our program, is to the ARS program as a whole, is to provide those types of guidance type documents, whether it be through reports or whatever, for the different types of reactors that are out there. You know, so for example, we may ultimately want to have, you know, a guidance document just for microreactors on what are all the regulations, what do you have to achieve, how your design changes would affect meeting those requirements, and then likewise we may do the same for pebble beds and molten salts, and you know, the different types of reactors that we might be presented with in the future.
Okay, is there any preferred reactor type?
No. Yeah. At this point, the program, especially along with the demo program, is designed to be supportive of several different types of reactors. So we don't, at this point, we're not, you know, there's nothing that's preferred or not preferred. You know, anything's on the table. It's mainly just, you know, addressing the MCNA and physical protection needs.
Okay, that looks like that's all the questions we have for this Workscope. Thank you, Juan and Ben. We will resume the webinar at 11 a.m. Eastern Time with CT-5.
Thanks.
Thank you.
Thank
Bye.
you.